Okay, you have an idea of how queuing works, and trust me, we are going to revisit queuing a bit later, but first we have to cover the foundation of QoS, classification and marking. Not all applications are created equal. Some are more important than others, and that means that some packets need to be given higher priority than others. The idea of a quote-unquote neutral network may sound good, but it's based on a false assumption that all traffic is equally important. During times of congestion, it may be necessary to drop or delay certain types of traffic in order to make room for higher priority traffic. This is what classification does. You classify traffic according to how you want it to be treated during periods of congestion. For example, traffic that's sensitive to delay or loss would be classified as delay sensitive and treated differently than traffic that is not sensitive to loss or delay. Differentiated services, or DiffServ, is a framework that uses the type of service, or ToS byte of the IP field, to classify or mark a packet. The way this works is DiffServ sets the ToS field with a DiffServ code point, or DSCP value. DSCPs are grouped into three different groups called per hop behavior, or PHB groups. The term per hop behavior is one of those ambiguous terms that's highly dependent on context, and the way people use it is not very consistent. A PHB is supposed to describe how a router treats a packet. That's the way the DiffServ RFC describes it. But in practice, a PHB is just an arbitrary way of classifying packets. So a PHB group doesn't actually dictate how packets in that group are treated. It's just a set of predefined DSCPs that you can choose from. These PHB groups are class selector, or CS, assured forwarding, AF, and expedited forwarding, or EF. The class selector PHB group consists of several different classes ranging from CS0 to CS7, with CS7 being the highest priority. The lowest priority code points are quote-unquote lower effort, or LE, and CS1. These are designed for the lowest of the low priority traffic, stuff that you might not even want on your network. Think of BitTorrent or online gaming. CS0 is the default priority, and it actually takes precedence over LE and CS1 traffic. By the way, notice that all of the code points end with 3 zeros, the one exception being LE, that lower effort class selector. So the class selector PHB is pretty robust and gives you a lot of priorities to choose from. But if that's a bit much, you may want to instead consider the assured forwarding PHB. AF lets you specify not only the priority of a packet, but also its drop probability, or drop precedence. What is that? Well, it's the likelihood that a packet will be dropped while it's waiting in a queue. AF has 12 different classes, 4 priority classes and 3 drop probability classes. AF code points use the format AF_XY, where X is the priority and Y is the drop probability. Lower numbers mean lower priority or probability. Higher numbers mean higher. Let's look at an example. Let's say 2 packets are waiting in a queue. One is marked AF11 and the other is marked AF12. Which one will be dropped from the queue first? The AF12 packet has a drop priority of 2, whereas the AF11 packet has a drop precedence of 1. So the AF12 packet will be dropped before the AF11 packet because AF12 has a higher drop probability. AF is good for TCP applications that can tolerate packet loss. Web browsing, database connections, and file server traffic are good candidates for assured forwarding. By the way, to find the DSCP value of any AF class, use the formula 8x plus 2y. For example, AF12 would have a DSCP decimal value of 8 times 1 plus 2 times 2, which of course equals 12. Converting 12 decimal to binary gives you 001100. That is the value that would be placed in the 6 high order bits of the ToS field in the IP header. Personally, just in case you're wondering, AF is my favorite PHB. The last PHB is expedited forwarding, or just EF. And this isn't really a group, unless you consider it a group of 1. It is a single code point with the decimal value 46, and it's reserved for high priority traffic that should be bandwidth limited. Voice over IP is the most common example of this. Voice traffic cannot tolerate latency, so it has to be given high priority, but you also don't want voice to saturate the network, so it also needs to be limited in how much bandwidth it is allowed to use. This means EF is not good for high bandwidth applications such as video. Alrighty, a couple final notes on PHB. PHB groups are not mutually exclusive. You can use code points from different groups. You don't have to stick with just one. Also, if you're ever stumped about which PHB to use, look at RFC 4594, titled Configuration Guidelines for DiffServ Service Classes. It'll give you some recommendations on which PHBs and code points to use for different types of traffic. Okay, so far we've talked about marking IP packets using the ToS field, but what about marking Ethernet and wireless LAN frames? The IEEE 802.1q standard defines a 3-bit class of service, or CoS field, that can hold what is called a priority code point, or PCP number, ranging from 0 to 7. You may hear this called the 802.1p field or the PCP field. Officially, the values don't mean anything, but the IEEE recommends people treat 7 as the highest priority. A value of 0 is the default best effort class, and a value of 1 is for lower effort traffic and has the lowest priority. Sound familiar, right? This is similar to the class selector PHB group. Now, because layer 2 frames never leave a subnet intact, the CoS field will not have any effect on inter-subnet traffic. No translation occurs between the CoS field and DSCP markings. The two are completely unrelated. However, it is possible to manually map CoS values to DSCP values. Also, because the CoS field is stored in the 802.1q header, it will only survive on trunk links. Once a frame traverses an access port, that 802.1q header is going to get dropped and the CoS field along with it.